Here we're going to take a look at arithmetic series versus an arithmetic sequence. So a series is basically when you add all the terms of your sequence together. So this is a series because we're adding. It would be a sequence if all the commas were, or all the pluses were removed and replaced with commas. So if you were just listing them, it is a sequence. But if it's a series, they have plus signs in there. So an arithmetic series is the sum of an arithmetic sequence. This one here, you're adding together or going up by 3, so it's arithmetic. And you're adding, so it's an arithmetic series. If it was 2, comma 5, comma 8, comma 11, it would be an arithmetic sequence. Now, there's really two main formulas that we're going to use for finding the sum of an arithmetic series. If you're interested, I can go into class, or go into it in class, and how to come up with these formulas. But for the most part right now, we're going to just go with these formulas. Now, A1 is your first term. A sub n is your last term of the series. N is how many terms you have in that series. And then S sub n is the sum of that series. Now, if you would take your A sub n, and plug in your arithmetic sequence formula right here for A sub n, you would end up getting the bottom one. So as we look here, we want to now find the sum of the first 20 even numbers, beginning with 2. So I'm going to start out by just writing this out a little bit. So I'm going to have 2, 4, 6, 8, and so on. And then I get up to 40. You might be wondering, 40? Because we need to list the first 20 terms. If we only went up to 20 here, that would only be the first 10 even numbers. And we wanted the first 20 even numbers. So we're going to take our formula. A sub 1 is your first term, which was our 2. A sub n is your last term, which is 40. And we had said we had 20 terms here, so n is 20, the number of terms. So in other words, we get 10 times 42, and multiplying by 10 is pretty easy to do. You just add a 0. The next problem, we're asked to find the sum of the first 15 counting numbers, beginning with 1. So that means we have 1 plus 2 plus 3 plus 4, all the way until we get to 15. You can see that it's arithmetic because you're adding 1 each and every time. So we can use our arithmetic series formula. We can take the number of terms, which was 15. We can take our first term, which was 1. We can take our last term, which was 15. So we have 15 over 2 plus, or in this parenthesis, we're multiplying by 16. By the way, I'm lazy. I like to do things in my head rather than just mindlessly typing stuff into my calculator. This is really 15. The divide by 2 and the 16 gives us 8, so it's 15 times 8, and so I get 120. So I have my formulas in the upper right-hand corner. We now want to go ahead and answer this question. We want to figure out the first 3 terms of our arithmetic series, so that means we need to list them with pluses. But you're only given your first term, your nth term, and S sub n. So that means if we were using our formula, we would know S sub n. We would know our first term. We would know A sub n, our last term, but we wouldn't know the number of terms. And you're like, but we're not asked to find the number of terms. True, but we need to figure out our difference so that we can then figure out what we're adding each and every time. So we need to figure out, first of all, n before we can help us figure out our difference. Because our formula that we had up here at top did not have difference in it. So we're going to find n, then we're going to use that to help us find our difference. So for the most part, I chose the formula that worked with what it is I was given. I was given these three, a sub 1, a sub n, and s sub n, and so I chose a formula that had those in it. So now we want to go ahead and solve this. I get 43 here, then I have to go ahead and divide by 43, and then to get rid of dividing by 2, multiply by 2, and I end up getting 6. So I know what n is. Now, I could go ahead and use this second formula right here on the top right, because I know s sub n. I just figured out the n right here. You were given the a sub 1, and we just figured out, and I could find my difference. But I would prefer to go back and use this one here, because it's a simpler formula. Once again, my a sub n I was given is 29. My first term I was given in the problem is 14. And I just figured out, so I'll plug that in, and now I can find my difference. So 6 minus 1 is 5. I can subtract 14, divide by 5, I get a difference of 3. Now, it said find the first three terms of the series. So I'm going to start out with my first term, series, so I need to go plus to add my difference to get to the next term. Add my difference again, and I get 20. That's my first three. We're going to do the same idea over here. Same problem, same setup, and this is what we're given. Try to work it out quickly, and then watch the video. So we plug stuff in. S sub n, don't know n, our first term, our last term. And then we end up getting n to be 5. Then we could use either this top right video or formula, or we could use the arithmetic sequence. Plug stuff in. Our first term is 11, our last term is 31, our n is 5, so 5 minus 1 is 4. We subtract our 11, divide, we get our difference being 5. So we'll take our first term of 11 plus our difference of 5, we get 16, plus our difference of 5 gives us 21. We knew we wanted pluses in there because the directions said find the first three terms of the arithmetic series. If it said sequence, we'd put commas in there. Now, you might be coming across your summation notation or sigma notation. It's this funny looking E. Gives you a letter on the bottom equaling a number that you start out with and another number on the top. And then it's followed by something here, which is your rule. Now, what we have right here is an arithmetic series, and we can write it in our summation notation right here. Our rule is what we're doing. We're starting out with 1 for our first term. 1 times what is 3, and that's 3 times 1. And then what are we doing each time here? We're adding 3. It's arithmetic, so we could use our arithmetic sequence formula to come up with our rule. The number of terms here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 30 is our 10th term, so if we start out with 1, we're going to put 10 on the top. 10 is the last number you put into your rule to get your last term. Now, if we were working this out, we'd take 1, plug into our rule, we would get the 3. This funny looking E means series or sum, so we got to put plus. Then you plug in the next number up from 1, which is 2, plug 2 into your rule, and you would get 6. Then you plug in the next number up from 2, which is 3, plug 3 into your rule, and you get 9. And you could write it out that way. So down below here, we need to evaluate this. We need to plug in 3 to be able to get our first term, and we get 7. Funny looking E, once again, tells you that it's series, so I need to go plus. Then I plug in the next number up from 3, which is 4. So plug in 4, and I get 9. Plug in the next number up from 4, which is 3, or I mean 5. Plug in 5 to your rule, you get 11. And you can keep doing that and list them all out if you wanted until you plug in 10. Plug in 10 here, 2 times 10 plus 1 is 21. Now, the top number is not necessarily how many terms you have, it's the last number you plug in. This is an arithmetic series, so we can use our arithmetic series formula to figure out our sum. So our first term was 7. Our last term was the 21. Our number of terms. Well, if we started out with 1 on the bottom and went up to 10, that would be 10 terms. But we're not using the first two numbers, so that means there's only 8 terms. So n is 8. So we'd have 8 over 4, or 2, which is 4. 7 plus 21 is 28. And we multiply, and we can get our sum. Now, if you wanted, you could have listed all these terms out and added them together by hand with your calculator or in your head. That's one way you could have done it. But you could just do it by using your formula.